Welcome to Digitized Spotlight, your lens into the best builders in consumer crypto. I'm Amanda.
And I'm Winnie. On this series, we explore some of the latest trends emerging in consumer crypto and chat with those building at the forefront. In this episode, we dive into how consumers may be able to solve one of the biggest bottlenecks to AI scaling today.
We chat with Tom, founder of Actual Computer, building a distributed network that lets local computers serve AI inference, whether that's a Mac Mini, a consumer GPU, or something in between.
Hey, Tom.
Hi, Tom.
Howdy, y'all.
Hey. So I was actually just at NVIDIA GTC last month, and I was like, as I was reading about Actual Computer, one thing that kind of resonated with me with my experience there was that it's becoming a bottleneck to power all of this AI infrastructure. Would love to learn more about your solution and how you're seeing an alternative.
Sure, yeah. So Actual Computer is making inference software, and that inference software enables local mesh inference inside the home and a larger grid of inference sharing across the globe. And so what we imagine in order to get around a lot of these problems, see the data centers, a lot of the problems with them is that they take an immense amount of power in one location to get up. And so getting the approvals for that power, doing all of the AC, doing all of the extra work, the water cooling in order to handle all of that, takes an immense amount of time and immense amount of coordination. And so an alternative is, especially for models below a 1T parameter class, is to run them locally on people's hardware. We are getting lots and lots of models now that are very capable of running on things like 3090s, 4090s, and other more modern Apple hardware as well. And so we are really focused on how we can bring together the very, very large install base of consumer hardware in order to provide that inference demand that NVIDIA GTC was talking all about.
Yeah, it's so interesting because I feel like Actual Computer uniquely sits in this intersection of kind of AI infrastructure, energy economics, consumer hardware, and of course, like what we here in crypto know and love is crypto incentive design. Can you kind of take us back on how you kind of got here? Walk us through, Tom, your background, what led you to launching Actual Computer and kind of the thought process, idea maze that got you here, and what was like early inspirations of it, maybe in Deepin or in other things that you're seeing?
Yeah, so the process for Actual Computer existing actually started nearly a year ago now, when I first started paying attention to Bittensor as an org, which is kind of how we accomplish our DPIN infrastructure as a whole. And so about a year ago, I purchased a slot on the registry of Bittensor subnets from the network auction. And at the time, they weren't deregistering subnets and they weren't doing anything with them. They were mostly just auctioning off more. And so I saw this kind of just an investment opportunity and a chance to do something kind of interesting in crypto. I'm a big fan of commodities, and Bittensor is fundamentally a way to trade commodities over the internet. And so that is what pulled me towards it. And then a couple months later, I was hanging out with my friends in Los Angeles, and we, as friends do, we gathered a bunch of Mac Minis and Mac Studios together.
As friends do on their in their spare time. I'm
In
not
our
saying this sarcastically because I that sounds lovely. That sounds like a lovely afternoon to me.
the Kimmy models had just come out. They were these like first 1T parameter models that were available to the public, which is like a big size, the kind of size that you really kind of need a data center for. But if at the time, if you had a couple of these really good Mac studios, you could network them together and you could load up these extremely large models and you could get pretty slow speeds out of them. And that was exciting, and that was like something that we were very hyped for. And we looked at that and we said, "Wow, this is kind of a new capacity. This is an emergent capacity that computers like are just on the edge of being capable of doing things like this for us." And so with that, we polished it up. I started packaging it up into a simple piece of software, get a little beta together, and package it with uh, that Bittensor slot that we already had that happened to be kind of the perfect vehicle to let us coordinate and aggregate all of the people who have computers of this capacity because at the moment it's a unique size range that you need to run models like this where normal people generally don't have this class of computer quite yet. You have to kind of be a nerd to choose to buy this class of computer, but they are available on the shelves. Um, and so the uh, the birth of actual computer, what created actual computer, was this perfect little confluence of working to get local models going, having this subnet slot ready and excited to get used, and the perfect wave of models finally reaching this point where you want to run them 24/7 and they're capable of existing inside of harnesses that can do things for you 24/7, which makes it so you actually want to own the hardware because you don't want to be paying that cloud bill 24/7.
As someone who's racked up, you know, quite a bit in tokens over the past few months, that just keeps re-upping. I totally agree.
Yeah, it's it's like paying the landlord for your whole life, right? Uh,
So you mentioned that Bittensor was helping you aggregate computers of the capacity needed to run this inference networking software. So for people like that aren't as familiar with Bittensor, and I know this is Subnet 95, can you talk a bit about how it works? How is it all working together?
sure, yeah. So BitTensor fundamentally, would that be a good place to start? Just like a quick blurb on BitTensor.
Yeah, that
Um,
would be great.
okay. So BitTensor specifically is a network that is setting out to make digital commodities trading possible. Um, it's an L1, kind of like ETH or Sol or whatever. It has this token called Tau. Everyone buys the Tau, and that's the thing that it runs on. Um, and the fundamental primitive that you can do with this Tau is you can get things called subnets. Subnet slots are effectively entitlements generated by the network, and they entitle you to a particular privilege, and that privilege is to issue your own token on the Bittensor network. So you get to issue your own token that's a subnet token of the Bittensor network. Um, we call those alpha tokens. And the owner of the subnet token or the owner of the subnet is able to decide the rules for how those alpha tokens are distributed. And so we create rules where people need to come to us or come to the subnet with an account with actual, a couple computers on their account. Those computers have to be of a certain capacity and speed. Uh, we look at where geographically those computers are located and how electrically efficient they are. And then using that, we decide rewards and we have those computers perform the function of inference. And then that function is used to aggregate the inference. We're able to sell the inference, and the network rewards the people who brought the computer through this subnet token. And so it's quite a convoluted process. It's difficult to explain without a whiteboard behind me. But fundamentally, you can think of it kind of like uh, we create this own little economy, and then you have a liquidity pool for that little economy to a wider world. And so that little economy is like the subnet token plus the good that the subnet token is trying to encourage. So for subnet 95, it is the token and the inference capacity of its users. And then that is kept in balance by the liquidity provided by the Bittensor network. And the Bittensor network has all sorts of mechanisms for how it decides to distribute rewards out to these subnets in order to help them grow and give them liquidity towards that token pair that I just described.
That was one of the best explanations I've heard. That was straightforward. Taking a step back, I would love to kind of get your take on the importance of like, you mentioned earlier and alluded to it, but like local compute, right? Like what are some parallels of this to kind of what we've seen in the broader deep in space with not compute, but like other categories that have run locally? And what's top of mind as you build actual computer? Like what's important?
Yeah. So local compute and specifically, I'm going to say local inference is really interesting to me, because it's a special type of compute that's becoming its own mini commodity sector and has a very, very quickly growing amount of consumption. And so when I model inference in my head, I try to model it a lot after like gasoline, and the kind of desire and demand curve that gasoline had when it was coming into popularity in society. Um, so the way that I personally think of it is like you have the raw electricity that's like taking oil out of the ground, and that comes from the power grid. They generate it through a multitude of ways. They provide it to people's homes, and then that raw electricity can be refined into tokens through computers. And so it's not a far reach to consider that refining very similar to like what happens at a gasoline refinery to crude oil. And then the end result is tokens, is this digitally transportable good that is widely demanded, rapidly is getting more and more demand, um, and is kind of fundamental to all of these different technologies that we're pushing and are becoming more popular and more important in the workspace. And so where I'm going with this is effectively that uh, local inference allows you to have your own little gasoline refinery, right? It allows you to have a way to not have to pay that premium on all of your demand. And especially as these things get more imbued into everyday life, weaved into different things you do, looking at your inbox, looking online, participating in social services for you. All of these things uh, don't require an amount of intelligence that is so good that you should be paying Claude for all of it. It's a lot of them can be accomplished with things that are uh, free and open and
Yeah.
cost hundreds of times less.
I saw a funny meme was like me using Opus to like perform the most basic tasks. And it's like, you know what I'm talking about? And it's like to like cut open some pie or something. I forget what it was. And I was cracking up. It's like me using Opus to send an email. I'm kidding there, but
Literally, and I find myself doing that too, right? Where you just like, oh, Opus, search my computer for this file.
yeah, you're like, we don't need Opus for that. Like,
Right? Like that was
you
um
should insert the meme so that people can see, but so funny. But I hear you.
Yeah, I guess so. In this local compute space, I think we've mostly, seen a lot of investment going into data centers and hyperscalers. Are there other players within the local compute or that are focused on, aggregating compute across different homes and laptops and computers and devices?
yeah. So disaggregated compute has been a category that's kind of popular in crypto for a long time. It's within Bittensor itself, there's a couple of groups that do aggregating inference. Most of them do it for data centers. So taking like data center class GPUs in disparate different data centers and pairing them and finding them demand. Um, there's a couple of groups that have attempted to do things where it's like local compute versions of this. Mesh LLM is something that launched recently from the Block Group that does a lot of this kind of local compute meshing. And then there is, things like Exo Labs and Olama and LM Studio that do local inference, but they don't generally have the network part attached to it. Um, and so there's a couple of groups that are doing this kind of a thing in the space. It's quite it's not a new idea to coordinate computers with crypto.
I was just say, is there like a specific ch challenge? Um, I guess like is there because I feel like the local compute players, they haven't gotten as much attention. So is there something that's preventing these from scaling? And I don't know if you've thought about that with actual computer.
Yeah, I mean, it's a good part of it is just like how fast are the computers. The computers that people are generally, if someone walks out of the Apple store and they spent $2,000, like how fast is that computer? Because that's going to be your average consumer experience. And so if the speed of that computer is relevant to the task you're trying to aggregate for, then you have a massive install base accessible there, right? But if you're only going to work with the people who walked into the Apple store and bought the $10,000 Mac, then like naturally your install base is a lot smaller. And so a lot of the networks that have aggregated this stuff have just required a level of compute and a level of uptime so far that isn't super accessible to everybody. And so because of that, it's turned into a thing where it becomes like a mini full-time job for these people, right? And it's like setting up a car for Uber rather than just like flipping a switch and letting it happen in the background for you.
Yeah. How critical is privacy to kind of what you guys are building when you're routing inference without kind of even ever seeing or storing the requests, and kind of does that resonate with folks?
Yeah, absolutely. I mean, privacy is like one of the biggest reasons that people find themselves attracted to running models locally for themselves, especially people who are in a more professional context, like lawyers is the classic one, doctors, where you want to be able to use the power of these models to like search through things, search the internet, construct ideas, do research. Um, and support work that they do, but they can't if they think it's going to be subpoenaable or it can or its records can be reproduced or any number of these things. And so the privacy question in my mind is like ultimately solved by going towards local compute, where you don't have to worry about like if T's get broken in a year, you don't have to worry about if the data center is like snooping on its requests. Um, the computer is in your house, the traffic doesn't leave your home, and so it's not going anywhere. Any of the questions you ask, you're not adding another vulnerability into your life. Not that we don't already have many.
Yeah, I'm sure it's like very top of mind with kind of what's trending right now on Twitter with kind of all the hacks and privacy. I guess like how do you think that impacts how people should be setting up their stack?
Yeah, I mean, it's mostly a matter of like putting up guardrails and not letting these guys search the internet on their own. They're very manipulatable. They really just go on the internet and read. And if you imagine like a ridiculously capable 5-year-old letting them onto the internet to read and check out this stuff, like there's a lot of stuff they could read on the internet that would do a lot of damage to themselves and the things around them. Um, and so I think part of that is having your compute local and private, but uh, just as much of just as much of it is like using harnesses that are security minded and like not letting them openly go out on the internet and start to communicate with other individuals who may or may not be good actors. I think we'll see more of that. Honestly, we're going to see a lot more hacks. Like as long as people keep putting these guys in charge of crypto wallets, like we're going
Yeah.
to see.
Yeah, the multi-sig and issue, I guess. So one thing you mentioned is that there's a particular type of hardware that's necessary for your network. And I've noticed that like consumer grade hardware is becoming better. Like consumer GPUs, Apple Macs with massive unified memory. I'm wondering like, are these changes in hardware helpful? Or like maybe they're still not good enough for your network?
No, they're extremely helpful. And they're really like what makes launching the network right now something that's quite appealing. Even the baseline level of Mac that's walking out of the store today, the M5 Macs are getting to a point with speed where they can like run a couple models that people consider to be like reasonably competent. Um, and so if you buy like a mid-range Mac these days, you end up with a piece of hardware that's extremely capable of running a model that people demand, something that's capable that we're able to find demand for, and so reselling the time off of it is actually functional finally for the first time, uh, just now, kind of.
That's helpful. Um, Actual computer, the name, is it kind of like a manifesto of some sorts? Is it, what does it mean? Kind of walk us through that. I'm curious.
Yeah, so it's called actual computer. So we make inference software, right?
Yeah.
Inference software is the software that makes the computer think. It's the you put the model in, it makes the model think. Inferencing is the process of thinking for that model. And so we named it actual computer because uh, say you took a TI-84 calculator, like a one of these fast calculators that I have in calculus, and you hand it to like a 7-year-old today, and you told that 7-year-old, like, here's a computer, right? Like
Mm-hmm.
they're going to tell you that's not an actual computer. They're going to tell you,
Got it.
right, that's not an actual computer. It's not. It's a calculator. It's I don't recognize that as a computer.
Yeah.
So we named actual computer this because we think that in the future, computers that don't think and speak in plain English and talk to people like this, um, they're not going to be actual computers. They're going to be like toys, kind of relics that can do things and are useful, but are no longer meeting the definition of what we as a society consider to be a computer.
Yeah, that's a cool name. So going back to Bittensor, I'm just wondering if you have any learnings around like how to properly run a subnet to get the output that you're looking for. It sounds like it might be early days for Subnet 95, but yeah, anything you have on that.
Yeah, well, it is very early days for us. We're just getting the product out of beta, starting emissions very soon. And so I wouldn't be able to give an immense amount of advice towards that. But the few things that I have learned is just like talk to the people around us, talk to the community, um, be relatively forthcoming around what you're doing and why you're doing it, and your ideas for doing it. And I found that people generally tend to be supportive when you're communicative and straightforward and able to provide a plan. And so that is probably the extent of my advice that I would hand out at the moment.
Is actual computer live today? Can folks kind of use it in any way?
The product is live. We're inviting about 100 people a day right now.
Cool.
Um, and the mining with the product will be going live in the next few days.
Oh, awesome. I guess to close this out, would love to do some fun rapid fire questions. Let's start with what's the most underrated piece of consumer hardware in the AI stack now?
The 3090 graphics card.
What is that for those who don't know?
It is an NVIDIA graphics card that was released in like 2020, and it was the best thing that they made in 2020, and they still rock.
Great. What's the most surprising use case you've seen for local inference?
Um, I saw somebody using local inference in order to drive more sales on Reddit for their CO2 detector brand.
Oh, wow. I love that. Why does that need to be on local inference, though?
Well, if you want the models to like role play that hard and get into a Reddit account and start to act like somebody and slowly
Mm,
that, you need to be able to tune their behavior down at the local model level.
got it. What's one piece of hardware everyone should own that they don't?
A MacBook Pro 14 inch.
Okay, cool. Tom, it's great to have you on Digitized Spotlight. Where
Wonderful.
can listeners find you and learn more about actual computer?
You can find us on x.com. Actual Inc. is the tag. I'm also up there, Tom A. Lynch, and our website. You sign up for our
Cool.
website.
I'm excited to try it out in a few days when you guys do launch.
Thank you.
Cool.
Yeah,
Thanks,
awesome.
guys. It was great having you on the pod, Tom.
Thank
Bye.
you, Winnie. Thank you, Amanda. Take care.
Thanks. Bye. Thanks for joining us as we chat with Tom. It's been awesome to dig into the local compute thesis and how actual computer is betting the power to run AI is already sitting there in people's homes.
Agreed. I love the idea of my idle Mac Mini being a part of this larger network and serving a greater purpose here. A lot to watch. Follow us as we chat with more founders building at the intersection of consumer and crypto. Bye.
Bye.